All right, so lesson 4.4, using congruent triangles. What CPCTC is what we're going to get into. Now, I know that's a big acronym, but what it stands for, CPCTC, is a whole lot easier to say. And we'll get to that in a little bit. But for right now, are these two triangles congruent by angle, side angles? Remember, angle, side angle. We have to have a set of angles congruent, a second set of angles congruent, and then the side in between those two angles have to be congruent. Well, let's see what we got. So right now we know that angle A is going to be congruent to angle D. We can see that with the right angle marks. We can also see that AP is going to be congruent to DP because they both equal 5. So we have a set of angles, we have the set of sides, so the last set is we have to be able to say that these two in the middle are going to be congruent, and they will be. So we can say that angle BPA is going to be congruent to angle CPD because those are vertical angles. So keep in mind, vertical angles are an easy one to prove by looking at it. Just like reflexive is going to be an easy side to prove. So keep those in mind. So all the things that we've been doing the last how long here is showing that knowing certain information, we can show that the triangles are going to be congruent. Well, if we know the triangles are congruent, then we can use this backwards and say, well, if they're congruent, then all their parts have to be congruent as well. At least the parts that match up anyway. So using that thought process, that's where we get what's called congruent parts of congruent triangles. And this is actually corresponding. Let me write it down here. Corresponding parts of congruent triangles are congruent. So the parts that match up. So if triangle ABC is congruent to DEF, we know angle A and angle D are congruent. Those would be corresponding parts. So the parts that match up. So if we look up here, you know, A and D would be corresponding parts. B and C would be corresponding parts. This side and this side. This side and this side. This side, this side. Those are all going to be corresponding parts. So we're going to shorten that up to just CPCTC. And if you say it enough, you'll be able to do it without getting tongue-tied. But CPCTC. So here's how this is going to work. We have a figure right here, which is actually part of an umbrella, if you think about it. That's what it actually is. So this is what stretches up and down, which makes your umbrella unfold. But anyways, that's what this is actually from. But we're given that angles 1 and 2 are congruent. So we have the bottom two here and we have the marks. We also know that SL and SR here are congruent. Again, we have the marks to show that. We need to show that 3 and 4 are going to be congruent. So how we're going to do this is we're going to use CPCTC. Now, before you can use CPCTC, is the triangles have to be congruent. So we're going to prove the triangle is congruent first, then we can say their parts. So the triangles we're going to use is this. So first off, we're going to start with our given. When you do these, again, first step, always the given. Well, what do we know from there? Well, we have a set of sides, we have a set of angles, so we either need another set of angles, which would be L and R, so that we could do angle, side, angle, which looking at these, there's really no way that we can look at them and go, oh yeah, those have to be congruent. Or we can do another set of sides, so we can do side, angle, side. Well, the two triangles we're looking at here are this triangle here and this triangle here. They share our side CS. So we're going to do CS is congruent to CS by reflexive. And look for that easy set of sides. If they match up, if they're on top of each other, they have to be the same. So now we can say triangle LSC is going to be congruent to triangle RSC. And that is by side, angle, side. Because we have a side, and then we have an angle, and then we'd have another side as we go around the triangle. So now that we have the triangles congruent, we can say our proof here, which is angle 3 is congruent to angle 4 by CPCTC. So, biggest thing with this, you will prove it by one of our sides, which remember it is side, 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 angle, side, and angle, angle, side. All right. Now, we're going to get into another one later on, but this is what we have right now, or these ones here. So we're going to prove it using that. Once we have the triangles congruent, then we can say their parts are congruent. Now, according to legend, one of Napoleon's officers. Now, what we're talking about is Napoleon Bonaparte. He was a military general for France in like the later 1700s, early 1800s. Military genius. His brand of warfare was used for years and years and years, and some of his tactics are still probably used. But he was the one that was like, hey, our guns right now are not very accurate, so we're all going to stand shoulder to shoulder so that we have a volume of fire and will be more effective that way. And so that's where, if you've ever seen like the movie The Patriot, or a lot of Civil War was Napoleonic tactics, where again they would stand shoulder to shoulder, shoot back and forth at each other until the other side says, you know what, we've had enough, we're going to retreat. And that was pretty much all because of Napoleon. Sorry for the history note there, but little tangent, sorry. Anyways, according to legend, one of Napoleon's officers used congruent triangles to estimate the width of a river. So where I was going with that is that he was very innovative and ahead of his time with a lot of his tactics and the things that he did so that he was successful on the ground with his armies. So this is one of those innovative things. So how he would estimate the width of the river was this. So on the riverbank, one of his officers would stand there. So he would look across and he would lower the visor of his cap down, and so that the visor was on the edge of the river. He would then just rotate 90 degrees here, so that then he could measure out how far that is. So where the cap would, his line of vision where the bottom of the cap would be, someone could stand there and they could measure that distance to know how wide the river is. Quite inventive again. But we're going to prove how that works here. So we're going to start, like always, with our given. And I'm going to tell you right now, there's 6 of them here. We're going to be able to do this in 5. So we're given that DEG. So DEG and DEF are both right angles. We also know that EDG, so EDG and EDF are congruent. So we can make that mark up top, and we know this is a right angle, we know this is a right angle. So knowing these are right angles, we can say that angle DEF is going to be congruent to angle DEF. This should be DEG. So DEG is congruent to DEF. Well, if we know they're right angles, by definition, we know they're both 90. So if they're the same measure, they have to be congruent. So this is going to be by definition. So we can make that mark. So this one here, congruent to that one there. So right now we have a set of sides. We have a set of angles. Well, what else can we do with this? Well, we're going to know that DE and DE are going to be reflexive. So we can mark that. DE is congruent to DE as reflexive. So we can make that mark. Now, as of right now, we do not have an angle side. I mark here right now, that's what we have. We have an angle, we have a side, we have a side. So that doesn't help us yet. So we still need one more piece of information. You know, I don't know why I marked DG and F there because we have angles here. That is my bad. This is where I got too excited talking about the history and I didn't think about what we were actually doing. So EDG. So EDG is this top angle. And I'm going to put a second mark there. EDF would be this other top angle. So again, I'm going to put my marks there. We also have our side and middle. So now if we look at this, now we have an angle side angle. So if I marked it right, we would be done. So angle side angle, so we can say that the triangles are congruent. So triangle, we're going to have EDF is going to be congruent to triangle EDG. And that is going to be by angle side angle. So again, if we see it, angle, then a side, and then an angle. So now that we have the triangles congruent, now we can say that EF is congruent to EG by CPCTC. And that's how that one will go. So, case in point, make sure you're marking down the right things. It will help you in the long run do these proofs. So my mistake, hopefully you can learn from and be better at. But again, make sure as you go through, you're making those marks, and that'll help you kind of how it flows. But look for those easy set of sides with reflexive, or look for those easy set of angles with vertical angles. Keep those in mind. Remember, before we use CPCTC, we have to show the triangles are congruent. Once the triangles are congruent, then we can say their parts are congruent. Let me know if you have any questions. Again, keep in mind, you can always go back, rewatch part of this, or pause it if you need to write stuff down. Don't forget that you can do that. If you have questions, please contact me, let me know, and I can help you out there too to try and answer things. So, until next time, we'll talk to you later.